guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. It's a dude.
Dude,
What's the differ?
the differ.
What's the dick for?
I
DePee was stupid. Shit.
yeah.
Come on, we just watched that clip the other night of Spies Like Us, where the one dude that says the other pussy. And he says,
right,
what's
yeah.
the dick? What's the dick for? He goes, a dick for? Yeah, it's pee was stupid.
Yeah. Okay, yeah, I get it.
Okay, so we got a 3P here that we got to do. Not allowed to show the customer's information. Oh, let's get the arm over the tag there. So we got a suite with DEIs, a Texas Star 667, and another Texas Star 667, but with the coolest fan mod I have ever seen on it. Turn that up so we're not divulging the... Oh, God. Man, you are not a very good helper.
Yeah, I don't know what to say.
Jesus Christ. We're joined with Big Rig Radio here tonight. He's hanging out. Let him come on over as he's on his way up to go see his child, who lives in Seattle. He's not really a child. You're like almost 30-year-old kid, right?
He's in his 20s anyway.
20s and already got the job, dream job of them all. Anyhow, some children have all the luck. This is the neatest little fan kit. This guy, I think, has built this.
That is way cool.
Look at them stupid low-profile fans, dude. There are fans up on in there. Look at that.
Huh.
That's slick. So I can't wait to see how he's how this is all put together. Anyhow, what he wants me to do is look at each one of these individually, do power wire upgrades on them all, and modify, repair, or fix anything I feel is necessary. Giggity giggity. Giggity goo.
Gee, I wonder if you can handle that.
I don't know. We're going to have fun with this. So this is the beginning, and I'll bring in about halfway on each box, and I'll bring in on the end of each box. Sound like a deal? Remember,
Sounds like a deal.
what's a dick for?
To pee with, dummy.
Stupid. We're sitting there trying to figure out what we wanted to do. If we wanted to IHOP it, or what, DoorDash it?
Or Postmates.
Postmates.
Or Uber it.
Uber or what? And I was getting ready to do the power wire upgrade on this one. See, I cut the power leads off. Ooh, float free. And I went and unsoldered this wire. That is held in by 2 strands.
Yikes.
2 strands. 2 strands. Look at that. Oh, I come off. And then we start looking at stuff like this over here. For the love of burned up resistor. Then we got this hanging out in free space. I think that somebody's trying to make it so they could super high drive the holy bejeez out of the bejeez out of the bejesus. What do you think there, Mr. Big Rig?
Looks like maybe, possibly.
Totally and maybe totally for sure. You notice that this resistor's all burned up too,
I
right?
didn't see that. Yeah.
Mm.
So I guess we're getting the snot driven out of it.
Somebody's been trying to put the hoke to the poking. The joke to the bajoking. And we got an aftermarket resistor down here, and this is what drives the meter.
Well, that's obviously aftermarket too.
No. What? I thought all Texas Stars come with brown 1930s, 50s, and 60s freaking resistors in them. God knows we've seen enough of them in the last 2 days.
This is very true. Of these too.
Home Chicken here decides he's going to bring a bunch of Texas Stars that were made in like the early 80s up here for me to work on. And then he wants me to go and convert them over to HGs, and then we figured out none of them work.
Oh.
No, it was a painful
Nightmare.
process. Now I want you to notice something about this here. See this?
Yeah.
You see that?
Yeah.
You see this here? See how many turns we got here?
Yes, I do.
Where'd we end up on ours?
Same place.
And it only took us 4 hours to get there. Oh, that was a smash. That was Junk drawer smash, man.
It's a learning experience.
Huh. Yeah. Bet you these are, what do you think, thousands?
Thousands.
Yeah. I think they're probably 820s, maybe?
Good chance.
Good chance, yeah. We learned a lot in the last couple hours. We took a couple boxes that were 2290s and converted them over to HG 2879s. And, I mean, grab one of the Cursive 2290s. It's been a while since I've seen one of those. This is legit old school here, man. Look at this. This is what was in the box. Look at them pretty old girls. It was so pretty I'd take them out and put HGs in their spot. Little did we know that it'd end up kicking our butts so bad because we didn't know how to, the proper turn ratio for the HG for this particular device versus what they had for these, because they had a completely different capacitance and loading ratio. I mean, look, that's O3D.
That's old
School, man. But we figured it out. We got it all working, and now we decided we'd actually do some things that paid us, right?
That's right.
So, anywho, that's what we found. This I just wanted to document this. I thought that this was priceless. As we can see, that was clearly soldered in there oh so professionally in the sweatshop in Mexico or wherever these are made. Honestly, after talking with that super cool dude the other day, I think they're made here in the United States. I'm on a mission to dispel the rumor now. I want to go meet those guys down there.
They're pretty cool. Good folks.
Good folks. I want to go meet them. Have a sit-me-down chat. That's exactly where we ended up. See, yep, and this one's wired out of phase too. See, if we look at the output transformer here, and we'll see that it's coming out this side of the transformer. That would be this side of the transformer here, but then this is our output side. So in theory, this is out of phase. In theory. All right, let's talk more work. First we'll do this. We're going to fix this. We're going to strip these all the way out. You have dual positives, dual negatives coming out of this thing.
Is that what's going to go in there?
Yeah, but I need you to double up on that.
Double up?
Double up. I need another black and another...
Oh, can do.
Thank you.
This thing's going to run.
Yeah, we'll put grommets back here, and we'll fix all this stuff up here, so... All right. We shall return. This thing is high drive. I mean, it's cruising. This thing is... It's like it's got 2879 in there for driver. It does. Believe that. No, 2290. Man, well, okay, so we did the power wire upgrade. Now, this is going to spawn a call from this guy. I just know it, but I got to bring it up. I had this friend way back when, Mr. Big Rig Radio, and his handle was RDM, which stands for Rubber Dinked Monkey. Okay,
right,
but not dinked, but like dick. Okay,
Yeah.
So
Rubber Richard.
Rubber Richard, right? Monkey, right? He had this suite that he had personally done the power wire modifications on, right? And he had it in like underneath the tunnel in his truck. He was driving a Holman truck. It's Dick Simons, right?
Okay.
Isn't that the abortion that Dick Simons turned into? Was Holman or something?
Your guess is as good as mine.
I'm not saying anything negative about Holman drivers, none whatsoever. I'm just saying it wasn't like Holman bought Dick Simons or something like that, or
I don't know, but Dick Simon's been out of business for a while. He just came back.
everyone's had the skunk on the side of the truck, right?
Right.
Anyhow, this has been a while, but it's stuck with me. The lesson stuck with me. What he'd done with each one of his boards is he'd run an individual 8-gauge wire out the back of his suite. And so the way he had the thing hooked up, because he wasn't supposed to have the thing in his truck at that time, because they had a big rule against it. You're not allowed to have anything attached to the, major corporation. They're going to, the guy that's already got the 32 pill and trying to run it off 130 amp alternators already shown up and burned the truck to the ground. You know what I mean? So
right.
they made a rule. So he was hooking his power wires up to his inverter leads. And so he's driving down the road, and he's talking his butt off. You notice his output power fell off, and he starts smelling smoke. He's like, oh no! Pulls that big 18-wheeler over, hops out, rips open that side box. Sure enough, his Sweet is smoking. And what had happened is 2 of his power wires had come off, and 2 were still connected.
Ooh.
But because none of them were linked together internally anywhere inside the box, he had a small problem.
Yeah.
Right?
Large problem.
So with this style of an upgraded power wire, we have to go and we have to add a jumper from here to here. So internally these boards are tied together just in case if one of these leads come off, we're not going to end up killing this box. It'll still technically run on this, but it's going to run at reduced power and it'll show up. But it's not going to run as well as this. So the reason I bring that story up is because I did this particular style of power wire upgrade, and you've got to tie the 2 boards together. So there has to be an internal bridge other than externally to protect your customer. The story stuck with me, Jemmy. I remember it. Quit sticking your bacon where it doesn't belong, by the way, you creepy bastard. Okay. 1,000 watt slug in peak, 1,000 in average, 5 watt slug in reverse. 2950, 5 watt slug in reverse between the 2950. And of course the Texas Star. 667V. No, it doesn't stand for vagina. It stands for variable.
Oh my goodness.
Oh my goodness gracious, yes. It's so weird doing this with somebody standing here watching me and staring right in my eyes as I'm talking to him. To look at the product. Quit looking at me. I'm not that pretty. Y'all seen pictures of me. I'm not that pretty. Okay, so what we're going to do is we're going to put a little bit of drive into this thing. Whole whopping 20 watts. Good pass-through tune. Turn the amp on. Now, our high-tech testing tool for preamp is in operation or not. Preamp works. Good enough for me. Bob's your uncle. Okay, 20 watts in. 700 peak out. What I want to also show you is look at how high that dead key is. Let's go ahead, we'll turn this around. One more time. That's a 0.5 watt dead key. Technically, we are most likely on sideband. We're sounding like we're on sideband to the other guy on the other end.
Yeah, it's pretty low.
But with 1/2 watt dead key, slow down there, hot stuff. I got to turn that thing around. Turn it around, mister. Not going that way here. It's getting us almost a 400 watt carrier. Now I wonder if that's why they had all this higamajibby in here.
Could be. Looks like somebody added all that.
Well, no, this is an actual Texas Star component.
Yeah.
A long great son of a bitch, but it's supposed to go from here to ground. And this is an actual Texas Star resistor, but it's in the wrong place. But the same value. You see that?
Huh.
Anyhow, as it stands, we repaired the variable, repaired that burn-up resistor, did the power wire upgrade on it, and then we moved. This is your power from here. Your RF comes in, goes across, goes through this resistor. This wire was jumped to the wrong side of the resistor in the mod. Whopping 20 watts of drive. 700 plus out. Not too bad. Not too bad on the spectrum. 1, 2, tickle my shoe. 3, 4. Stick it in her front door. We're not talking her horizontal smile, we're talking her vertical smile. Got down. Okay. So now my friend here wrote in the notes that he talks mostly sideband. So, listen, if you talk sideband, you're going to want to have both of these in. 1, 2. 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 All right. Take the dial of watt out. And I don't know if anybody out there ever really knows this. You've got your on-off switch, and then this is technically medium, and that's technically low. Did you know that?
I didn't know that.
As you start punching in these switches, it starts tying in different banks or resistors of attenuators on the input. Did you ever notice that your output changes on AM when you start punching these switches?
Yeah, crazy.
Without moving the dial-a-watt. So this all the way open is low, and then you got a variance of low off of that. Hello, 1 2 1 2 1 2 1 2. You never noticed that?
Heck of an attenuator.
Right? So here, let me do that again so everybody can watch what I was doing. So we're on sideband right now. Dial-a-watt's out. Hello. Dial-a-watt is out right now, you guys. Hello. Hello. Hit the delay. Hello. 1 2 1 2. We fell off about 50 watts over here. Now let's go to low mode. Hello. 1 2 1 2 1 2. Now what we can do. Hello. Hello. Just pointing that out for operational standpoint. Now this is the way this is going to sit. I think I'm going to park this and wait until I can talk to my customer tomorrow and see what he has to tell me, because his note was all full of excited happiness and joy and pleasure. Now that I've had his amps for 5 months, I don't think he's going to be joyful and pleasureful on the phone. He's going to be like, hey man, where's my shit? But I say I'm freaking busy.
It's coming.
He's been here now for like 4 days. There's a lot of shit in this room, isn't there?
There is. You can barely move in here.
All right. We're going to stop here for now. And I'm really interested to see the fan kit on that other 667. So that's where we're headed next. We're going to set this one aside till I can talk to my guy tomorrow. We shall return. This is epic. We've been standing here for like 5 minutes going, wow. Now I read the guy's note. I read my customer's note, and I'm almost sympathetic to this situation.
We've all screwed up like
We've
this.
all made mistakes. It's been a while since I've seen something this bad. You know them Toshiba transistors are like $105 a piece now, right?
Probably like $115 after you pay the shipping.
Oh. And this is wicked wrecked on the inside.
Yeah.
This is like John Holmes wrecked the guts out of something, wrecked it. I mean,
I wonder if flames were pouring out of the box.
there had to have been some flames.
A lot of smoke for sure.
Right now they're saying we're grandstanding and we're talking smack and they want to see what the hell we're talking
Well,
about.
I mean, do you just look at, just show the lid. Yikes. How thick is that?
That's the hole inside of the tin, dude. Somebody took their hand and tried to wipe it at one point. Wow, that sucker exploded. So here's the front, right? Here's the slice bevel of the front. So somewhere here in the back, something seriously let the smoke out.
Which part?
Oopsie.
I think it's cool how it looks like it got like a can of paint dropped.
Yeah,
in
it's
it.
like exploded confetti. Look at this. I mean, this will clean up in 2 seconds. It's just really pretty to look at. This is epic. So,
This is like a new style. This is like a DEI style.
this is like a voltage regulator that they got to control the fan. So when you turn the on-off switch on, it's going to kick 12 volts down here to this trace. They're running it through a regulator for both of those fans, but how they've bypassed all of the input network on this completely. So they still have the variable here for whatever reason, even though it's technically bypassed. Then they got 316 coax, which is not stock, going down here to the input. And the input's what exploded on this. Look at that. Wow. Oh well. We can sit here and oob and ob on this all night, or I could just go clean it and we move on. What do you think we should do?
I think you should clean it and move on.
That's impressive. That's impressive.
Wow.
That is impressive. And it's one little part that did all of this. One little tiny part. Well, that and all the 4 transistors. I mean, because that 10 ohmer's gone. That 10 ohmer's gone. That one's gone. Gone. That one's gone. Hey, did we ever order food?
We did.
Okay, cool. I used to do these kind of power wire upgrades, and then I actually studied it where I, measured what the current draw was to the circuit, and then I did these kind of upgrades, like this here, at one point. And I actually used Teflon wire. I think that's pretty cool, too. But we weren't seeing any significant increase or any change in current draw, so...
Yeah, we were just talking about the crossover on the last box.
But there is no crossover here.
Yeah.
So this trace needs to be tied to that trace, which I will probably do with a piece of Teflon. Yeah. That's impressive. Damn it. Damn it. Damn it! Yeah, it's been so long since I shot the last segment for this little guy. I don't even remember where we left off. I know that I was documenting how badly this thing was torched. It was smoked. This thing's been on the bench, off the bench, on the bench, off the bench, on the bench. My buddy Zane from Big Rig's been here. Big Rig Radio, he's been here for the last couple days, and we've been busy working on his projects, and it finally back over to this one. So let's see. I cleaned it all up. I put 4 brand new 2879 Toshibas in this thing. Had to go in here and do a little bit of repair solder work, because when that 10 ohmer went up on this transistor, it was incredibly violent. I actually caught the board on fire. I caught the fiberglass board on fire. But we got it cleaned up. Had to replace the input tuning capacitor because, well, this thing got overdriven just a little bit. And things started falling like dominoes. First dominoes to fall down were the transistors curling in and giving up. They're like, nope, can't handle it. 700 watts drive's way too much. Man, I don't know what happened. The dude put 700 watts of drive into it. That's all I know. So first the 10 ohmers went up, and it went up so violently that this 10 ohmer exploded, caught on fire, and got so hot that it caught the board on fire. Then once the RF didn't have any other place to go, it went and it burned up the 100 ohm splitting balance resistor. Okay, so the RF comes in, goes through, comes around this 316, which is not stock, goes in here, hits this balance resistor, and then gone, right? Took it on to Mother Earth in the sky, just toasted that resistor. Then it went and it found the next pathway that it could find to ground, which was this cap, and disintegrated the cap, and by then he'd figured out that he'd done something wrong and unkeyed. So I cleaned all that up, cleaned up all the connections on the input, got all this rewired and repaired. Like, had to do a bunch of solder work down here. I didn't see that till this morning down here on the output trace to help carry a little bit more current. That and it a little scooched. Then I came along with Teflon wire. And internally I bridged these together. Now that wire will get hot as friggin' snot, right? But because it's Teflon, it will never burn. So just in case one of these leads come apart down here, which I highly doubt they will, because I was sitting there looking at this and I'm like, man, this guy had this in an Anderson clip and he sweated the Anderson clip off before he sent it to me. Don't do that. I've got Anderson clip adapters. It's okay. Send them. I've got every kind of commonly used adapter, period. Welding plugs in all 3 of the common sizes. I even got these tiny, tiny, tiny little ones. They're really cute. They're like 50 amp little slip lock welding connectors. Every kind of Anderson clip. Don't take them off. Just leave them on, guys. So that's the only reason we didn't change the power wire configuration for the most part. Internally, we just repaired this thing and made it happen for this guy. Hold on a second. Sorry about that, guys. My wife just literally walked out mid-sentence and started talking to me. And she goes, man, I never know when you're filming or not. And I said, do I need to get an on-air light? And she goes, yes, I would love to have an on-air light so I know when you're recording and when you're not. I happen to have me one of them. Oh, My buddy Big Rig hooked me up with this a couple years ago, and then I took it over to my vinyl guy and had him print this up for me. And it was when the goal was to get above 50K, and now that I'm finally above it, this sign's kind of pointless, but this is what I dig about it. Not notice that. So I have to come up with a way to power that up inside the house so she knows not to burst out here into the shop. Anywho, let's get back on topic. Let's see. Where was I? Oh yeah, internally, just in case if these two leads ever come apart, and they probably never will because this guy's obviously using an Anderson clip the way these are soldered. They're perfectly symmetrical, just like the inside of the Anderson clip lug. Yeah, don't pull your clips off, guys. I've got that covered. Trust me. I'm so used to having stuff show up here that... Anyhow. So, let's run it through its paces. This has got the coolest little fan kit on it I've ever seen. It's quiet. It's incredibly low profile. It utilizes, well, it'd be cooler if we could modify this face and let the air come out this way, but pushing air in, and it's coming out the back, and there's quite a decent volume of it at that. Just tiny little fans. So I love it. Let's go over here and run around the lab. 1,000 watt slug and peak, 1,000 average, 5 watt slug and reverse back from the Bird, 10,000 watt dummy load. Let's see, what radio do I actually have hooked up? I have the Striker. Sorry guys, I'm bumbling around. I got like 7 million things on my plate, and I'm doing everything I can just to get through this afternoon, and it is Sunday, by the way. So, let me cover that real quick. The reason that I don't get too carried away about preamps is because the transistor that's in here, as soon as you put power to it, it automatically adds 20 dBm worth of noise floor. And it doesn't matter if there's no antenna and you're on a closed loop. Preamps are the most worthless thing in an amplifier. So listen, there's no noise. We have no input signal. That is created noise from the transistor doing its job and just amplifying. There's very little filtration. There's very little cut control. There's no noise gate. There's no nothing. It's just a wide open raw transistor. So when you kick the preamp on, what you're more or less doing is just rectifying noise. Mostly just noise. Now they do make some transistors out there that have incredibly low noise rectification gain force to them versus the overall signal amplification that they're going to achieve on a chart. Do you seriously think Texas Star is going to have that transistor in there? Or Palomar or any of the other guys out there on the face of this earth that build and manufacture preamps internally on an amplifier? No, they don't. We have access to those transistors, but each one of those transistors is about $10, $15 a piece. The good ones, the really good ones that don't create a lot of noise. Where your best modification for preamp or actual receive is going to be inside the radio. Like this radio here's got a special transistor in it with different Schottky diodes in it and a whole bunch of other little goodies that, like on a quiet electrical day, your buddy that was, 20 miles down the road, and it's not just turning the needle up inside. By modifying the transistor, your noise floor drops. And by changing some of the other satellite components around the transistor, your signal, your noise floor on the bottom goes down. So the amount of noise that you're hearing, which is usually transistor noise when you've got a zero signal, goes down, and then your signal increase goes up. But if your technician is smart, he's going to put an X amount of signal into it and know that that's going to equal so many millivolts or milliamps, millivolts. Sorry, it's been at least 10 years since I thought about working on radios. So many millivolts worth of signal is going to equal X amount of dBm on the receive. And they'll adjust that with an actual input signal generator. But there's a whole lot better ways to get better receive than this. So we can get really excited about preamps if we wanted to. Not my thing, not interested in it. I'm in an RF amp business at the minute. So All I'm doing here is I'm showing that it's actually rectifying something, because the quality of what it's rectifying is so poor that I don't even recognize that as something that I should be interested in other than that it's working. Okay, now that we're done with that little tangent. Whew. 80 watts drive. 20 average. Nothing back from the bird. Pass through tune over on this meter. Audio. Absolutely nothing going on. So we'll start on low, and we'll start with sideband delay. So we'll start with our sideband delay. And like I've said in the last couple videos, I don't know if you guys recognize it or not, but that's low, medium, high, and that's with the variable all the way open. Otherwise, medium with variable, low with variable, variable. All right, so we'll start out on low. Now, I'm showing you all these different functions like they do anything, and this just clicked in my head. But look at the path of the RF. It has literally been bypassed for the most high drive that you can get, and it's got a variable in there. And if it was up to me, this variable would be out of here. So brother, please remember, run this all the way wide open. So let's stand on this now. Otherwise, working exactly as advertised. Totally forgot about this. I think I even covered it in a previous segment of this singular video. You guys got to remember, that was a couple days ago. Lots of video strings going on in my head. I got at least 12 things that I'm working on right now that I've got certain segments of the video shot, like the beginning, the middle, the ends, in between, the repairs and the monologues. Getting a little bit crazy in my brain. This thing's done. So, the last girl to the party is this rare unicorn specimen here. This is a Texas Star Sweet 16. It does have the aftermarket fan kit that came with it. I already took it off. I don't have all the plugs for the fan kit, so we're not going to get to see the fan kit run. But I see that we're going to have to replace some caps. That's what those are for. We're going to come through. We're going to give this a full power wire upgrade. We're going to do the fuse bypass. We're going to get rid of this here. This is a good attempt. They actually hydraulically crimped the connections here. That's a good attempt at doing something good. We're going to do something even more fun. I am going to do something completely different than what I normally do. Normally I drill a couple holes here and have a distribution bar, and I think what we're going to do is we're going to stick with the common theme. We're going to have a little bit of fun with this. I think we're going to pull all the fuses out. I think we're going to eliminate most of the power wires in here. We're going to have a common positive bus bridge go between each one of the boards. I think it's going to be really cool. We're going to recap it. We're going to do some B+ upgrades. And then I want to get with the customer, and I want to make sure that we want to have the fans on this actual thermocouple. I was sitting here thinking, is it a thermocouple? Is it a heat variant switch? I'll settle with thermocouple on this one. I'll call it a heat variant switch in the next one. We're going to do some other little fun upgrades in this thing. So let me get on the phone with the customer, because now that puppy's fixed. I'm going to throw the tins on it. We're going to set it aside. And when we get back, oh yeah. We all know what causes this. This thing's been burned up and repilled. Yeah. At least it's a matched set of Toshibas. Yeah, we better hook this up and run it first before we go any further. I think really this is how this should be run. Striker into this little guy. I don't think there should be anything in between. All right, 1000 watt slug in 2X, 1000 in average 5 watt slug in reverse. 1200 peak. It's perfect. So we're good, is the point. 8 transistors are good. We're just going to go in here and we're going to polish this up. There's things in here that your eyes will start to see. This is the way they come stock. There's things in here that your eyes will start to see that you're going to start to question. You go, well, wait a minute. Why are those laid over like that? And when you start to look at the solder work, you'll see that the capacitors were at one point standing up. This box got really hot. Usually it's because of this. If you got a fan kit and your amp's getting hot, it's because your fans aren't on when you first turn the amp on and start talking on it. Whole amp's got to get hyper-saturated with heat. Then the heat's got to wick its way up through the board, usually carried by this one screw, heats up the componentry, the board itself, and then causes a switch to kick in. The air hits the switch, gets the switch cool. The board and the amp is still screaming hot, but it's getting the switch cool enough that it'll cause the amp to kick off. I mean, I get the whole auto fan thing. That's really cool. I've got a lot of boxes that have shown up over here over the years that are burned to the ground because of this. Not a big fan of that, but it's one of the things I'll cover with the customer. Don't be surprised if this gets deleted. But these caps have fallen over, so I got to clean this up. Yeah, they didn't do too great of solder work in here, I'm here to tell you. See, you look down in here. I got to capture this. Let's see here. Let me show you this like this. Let me grab a flashlight here. And if this strobes on camera, I apologize. I haven't had a chance to sync the flashlight to the... See, if you look down in here, you'll see some solder joint work that is starting to get catastrophic. You see those two little globs of solder? That's from the face of the transistor getting so hot. And look at how close that is to almost making contact with ground. But the same thing going on here. You see that? Pretty much the only thing that's insulating that thing from shorting out is the flux. Now we'll go look at one that isn't melted down, and there's an actual physical gap. There's a piece of phenolic that's there. You can see the phenolic, and then you can see the trace phase. That's what's insulating that. I got the same, this one's clean on the tail end, Charlie. That one's pretty clean. So you gotta look at all the little details. Look around the little cat fur in the dust. You see that? You can see where the caps have literally laid over. Sometimes you gotta slow down and look, not just slam new transistors in it. Okay, let the shopping begin per se. The other thing he told me is that this relay's sticking. We're going to modify that. What causes that is the armature inside the relay moving back and forth all the time. Well, there's no springs inside of that relay. They're driven by magnetics. Okay, and the armature moves this way instead of vertical and horizontal. Armature moves this way internally. So you have this big giant flat surface area dragging on the surface on the inside of the relay. So after about 4 or 5 years of constantly clicking back and forth, 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 starts to drag. So it's like I told him, I've got replacement relays for this thing. But then again, we can go that route. I said, or oh yeah, I want to have another conversation about these another day. The 8 amp labeled but 5 amp Omron relays that current other builders are using, claiming, oh no, we can run a 4-pill through these. No, you can't. These are Omrons. And on here, it's labeled 5 amp in this particular bag. And on here, it's labeled 8 amp. Can we say somebody got some reprinted relays from China? I gotta cover that. We'll come back to that another day. I told my customer, I said, I got a solution to your problem. We're gonna go to a mechanical reset relay, otherwise spring tension. The coil here charges, it pulls the armature down, we have a physical connection, and then we're not relying on magnetics and surface tension and pressure and all that stuff to reset the relay. we're going to have a physical reset. So I'm going to go ahead and I'm going to drop this in here and slightly modify this amp to hold this connection. This will never fail him. This, 3 to 5 years worth of use, we're going to have failure again. Sticky is what they say. The relay's sticking. Yeah, it's only a matter of time, and it slowly gets worse and worse and worse and worse and worse. Just saying. Shall return. So I got all the positive wires pulled out of this, you guys, and this is what I found down here. So 1.2 ohm resistor that Texas Star uses as part of their bias control circuit. So each one of these boards has its own independent bias circuit, and this one here is fried. But we know these transistors are working fine. This is probably burned and nobody's ever bothered to replace it. So I'm going to do a quick change on that, and I just had to video it real quick. Okay. We're at the tail end of this little saga, finally. What I want to show you guys is the inside of what one of the relays look like on the inside of a Texas Star 1200 and 1600. This is the whole movement. This whole thing. There's a little magnetic strip here and another little magnetic strip here. Forgot to mute my phone. And that is what forces the physical return of the armature movement. Okay? So now if we look really close at this, we'll see the gap in between the relay points. How it works is the RF comes in here, goes out here, back to the coax connector. And when the armature moves, it takes this wire, well, this wire here, and attaches it to here. So your leads come in from your coax connector, like this. Okay, and the way this crosses is when the relay is relaxed and the magnets have the relay pulled to an open position, or closed, however you want to think about it. The RF comes in, goes across, this pin comes back out over here. Your output RF goes here, and your output RF, or your input RF goes here, and your output RF goes here. So you have this contact right here, and this contact right here that your RF is traveling through. So now let's say you're on sideband. This contact here and this contact here. Let's say you're on sideband. Those contacts are like points in a car. I was explaining this to a guy the other day. He wanted me to build him an auto keyer for a 3000, and I said, no, I wouldn't. He goes, why not? And I said, because it's like striking the points in your car. He goes, what do you mean? I said, well, think about the old point systems that we used to have in the cars. And as the thing would spin around in there, the points would burn up eventually because they're opening and closing so many times. Well, imagine doing that with RF. It's striking a little lightning bolt inside of here every single time it opens and closes and opens and closes. And what I noticed with this particular relay is, I don't know if it'll let me focus on it close enough, but there's a V that's burnt in that contact point. You see that? The focus right there. A little cut in it from the relay opening and closing, opening and closing. And you'll see the same thing on this one, except this is in a relaxed position. See how the contact isn't even anymore? Here towards the back side of things, over here, the contact is actually melted down a little bit. So what causes these to fail is either the contacts get dirty from you sitting there talking sideband and the relay going chatta, 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 chatta. So you go audio. Oh, blah, 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 blah. Your friend, blah, 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 said blah, 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 blah. And then if you're talking kind of a little bit slow, this is the way the relay moves. Either you get dirt on the contacts, or what these relays are notorious for is the bar magnet stock on this thing. Either be a little bit more weight on this side or a little bit more weight on that side. Okay? What that does is it causes this shaft that the whole Cucamaractus Rockamanjockamus here decides it's going to ride on and pivot back and forth on, starts to wear. Not perfectly balanced. You can't mass manufacture these and get this like totally balanced. So you always end up having the shaft spindle that's just a little bit more worn out than the other, and what it ends up doing is it ends up dragging either on this side or this side, and there's not enough mechanical inertia to fully close those very abused points. So if you're a serious sidebender, one, you're going to want to go and you're going to want to get yourself a manual key. So either you can step on a foot pedal, or you're going to have your radio, as soon as you spike the mic, before the RF chain gets excited and has any energy in it, you close the contact. Then the RF can flow through with no resistance, no arc. And then when you unkey your radio and the RF chain is no longer excited, you release the relay. Much easier on this very crucial component. All right, now I've got that explained. Gentlemen, let's look at what I created. So we got rid of this little tiny garbage wire and went with an incredibly high strand count wire. We upgraded the relay, we completely recapped the box, and we did some other power wire upgrades on this thing. We went to a solid copper bus on the back. We went to a single piece of 8 gauge or 4 gauge feeding the amplifier and 2 pieces of 8. And I did that intentionally. After talking with the customer on the phone a little bit this afternoon, he explained to me how he's going to go about feeding the power to this thing. Makes perfect sense now what he's doing. And so I tailored this to his actual needs. So this is a solid copper bus that's in the back, just a little piece of like 20 thousandths or 60 thousandths or whatever it is. Copper bus, 4 gauge comes in, it's direct soldered, and then independent distribution leads bypass the fuses. Okay. Then we upgraded the relay, and this is actually soldered in place. This is not ever, it's never going to move. We extended all the leads and put everything back the way it needed to be. Now, you got to remember the input circuit on these things is very induction sensitive, okay? So the length of the trace from here to where the old relay is at, that's the reason I had to add this extension bar to this capacitor. Got our little new snubber in here. And this is, let's see, what is this thing? It's a 30 amp relay. If you wear this out, man, I'll be impressed on you, man. That's, this little guy here, I don't remember what these are rated for. Oh yeah, 10 amp. 10 amp relay. Went through and fixed all the caps, redid all the solder work on the input transformers where the solder had run down and was almost ready to arc out. Gave it a little B+ upgrade across the backside as well. I've been having fun. I don't normally do that because it's such a small amount of measurable difference. We're talking like maybe 5 watts per 2-pill section, but it all adds up. Bypassing the fuses, it allows you to pick up about another 15-20 watts per section. But reducing that resistance overall equals less heat, more key down time, more operation. Now, I did this big, huge spiel about this little freaking thermocouple here. I get on the phone with the customer and he tells me, oh, well, I don't use the internal fan circuitry at all. I have another external supply that I use that I run the voltage down. That way I don't have to listen to the fans roar away in the background. I just kind of tickle the fans at 9-10 volts. And if the box gets a little warm, I turn the fans up and it cools right off. And I was like, brilliant, absolutely brilliant. So I didn't have to deal with any of that. I went through and I rehand tied everything by hand. Everything is slacked, rebent, retextured, reformed, reshaped, And the next thing you know, she had an orgasm because we hit the G-spot. I'll show you the G-spot here in a second. Got an actual Hakko strain relief on the back. Got a grommet on the ground. We removed one fuse. That was fine because that fuse block actually itself, the inner plug was missing. So it was non-functional anyhow. We just took it out, drilled this hole out a little bit, added a grommet, used the stock hole with an actual Hakko, brought 4-gauge wire on the inside, replaced the leads coming in off the coax connectors, and then this is what I thought was really cool. Let's go up here. Now let's see. It's a 1,000 watt slug in 2X, the same as we had set up before. 1,000 watt slug in average, 5 watt slug in reverse, back from the Bird 10,000 watt dummy load. 955. 5 watt slug between the 955 and the old Texas Star here. Now I was expecting that because I added about, maybe 1.5 inches worth of extra wire here, plus the length of the leads and everything on the inside, that I'd have to put a pass-through capacitor going from here down to ground to help tune the pass-through. So check this out. This is our striker. Hello. And so that makes sense. Let's come off of 2X. Let's go down to 1X for you all. Hello. Here's our nice 80 watts going through the meter, or going through the amplifier. Here's our pass-through tune. No capacitance necessary. Now, I don't know if you guys can remember back a couple segments ago. We drove it with this exact same setup on the same voltage, same watts, same everything. All we did was go in and clean everything up, change the relay and modify the power wires. It did roughly 1,200, nothing more. 1,000 watt slug fully deflected. So if we times that by 2, that 50 mark right there, that's 1,000 watts. 1,200 was at the 30. Let's see where we end up now. This thing turned out phenomenal. Hello. Like I said, it all adds up. Hello. We're scooching up to the 30. Let's look at our average numbers. Hello. Picked up numbers there too. So watch this. The hardest meter in all the land to make read flat. Stupid striker meter. I can have this needle laying on 0 no matter what I do, and the striker will tell me I got an SWR, input SWR3. So, hello, hello. That's not even 3/10 of a watt of reflect, but look at what the striker looks like. Hello, 1 2 1 2. Hello, 1 2. It's beautiful, is what I'm getting at. So, brother man, we picked up 200 watts in performance just by cleaning it up and making it fully functional. This relay will not stick on you. It will not. And these things are super easy to clean. That's the reason I like these. If you have a problem in the future and you start to lose receive, you take a flat blade screwdriver, small, like this. Make sure your power wires are disconnected. There's a little tab right here and another little tab right here. This whole thing slides back about almost 1/16 of an inch and comes straight up. You have full access to the frame on the inside. You take a $1 bill or a $100 bill. It doesn't matter. They're made of the same paper. The only difference is the frickin' stuff that's printed on them. Fold it over 3 or 4 times and then go in there and very carefully clean your relay points. Just about the right thickness, just about the right texture. You take your finger and you hold it down on the $1 bill on these bottom points, clean the bottom. But your receive is totally done through these 2 top tabs. Cool? Cool. Guys, it's 8:30 at night. I'm going to sit down, I'm going to start editing this video. That means probably about 10:30, 11 o'clock at night, I'll be able to post it to old YouTube for you all to start to enjoy. It means I probably won't get to bed till about midnight, just simply because of video production. So on that note, I'm going to say, guys, I appreciate you all tuning in and being so patient and waiting and watching me do these last 3 amplifiers. Gentlemen, my name is BBI. With great pride and a whole lot of energy and effort, I got to say I am the biggest mud duck in Idaho. Come check us out on Facebook, Twitter, Snapchat, Instagram. Well, I don't do a whole lot with Snapchat. And Instagram's kind of a so-so thing. Come follow me on Facebook. If it's your first time watching this little dog and pony show, do me a favor, do yourself a favor, make both of us feel good, deep down inside, in the cockles, the depths of our hearts. Click subscribe, make sure to hit the notification icon. That way you know when the next one of these little amplifier porno videos come out. Guys, I gotta go. Remember, we're selling hats, jackets, and shirts. All you gotta do is send all your contact information to BBI Shirts or boxbuildershirts@gmail.com. I'm tired of everybody texting me and asking me. I'm not big for plug-in swag or trying to sell anything. I'm simply out here just promoting the video, and I'm totally screwed that up at the end. But I'm gonna leave this in the video because I don't care. You'll probably never hear me make another mention of it ever again. Guys, I gotta go. Appreciate y'all tuning in to watch the porno. Let's get this sucker in the can. I'm gonna go die now. Bump bump from your friend in Idaho. I'll see you. Bye. God, I keep forgetting I totally built this. I built this radio just for this test. Right here. Striker 490. Into the suite. Hello. I've got the AMC limiters and the mic gain back so I don't overdrive it. But this is with the full 120 watts worth of power you should be technically putting into this guy. Flip that switch up to the 2x position, just where we were at. Ready? 120 watts worth of drive. Hello. 11111. Hello. Hello. 1600 watts of peak power. Now we can call it wrapped. Man, this has been a long week and a long weekend. Whew. I'm going to sleep the hell out of my bed tonight. I'll see you. Bye.